our very own Pierre Law Firm Bra. He's one of our data strategists. He will be leading and running this session. For those of you that don't know Covenant, we're a premier Microsoft consultancy here in North America. We're actually headquartered here in St. Louis, Missouri, where I sit as well. And we've been a Microsoft partner going on about 20 years now. So we were one of the first partners to actually adopt Microsoft Fabric years ago, back when it was actually still called Project Trident and only available in private preview for some of their premier consulting partners, such as us. So we have a pretty interesting take here and have had hands-on experience for a number of years now. Hope you guys enjoy the presentation. With that, Pierre, I'm going to turn it over to you.
All right, as Martin was already kind of alluding to, we'll be talking about AI features and Microsoft Fabric this morning. So let's jump right into the agenda. First, there is an expectation that you have at least some general understanding of Fabric. I will be doing a very, very brief overview of Fabric, but we won't be spending much time explaining what Fabric is this morning. Then we will be going into Fabric's CoPilot features. It's very similar to a lot of the other Microsoft Copilot experiences across their suite of tools. And we won't necessarily spend a lot of time again looking at the what of Copilot in Fabric. We're going to spend a little more time on how to get the most out of Copilot in Fabric. Then we are going to kind of pivot to a relatively new feature in Fabric called Data Agents. This was previously called AI Skills. It's been renamed to Data Agents recently, and we'll talk about some of the features there, and we'll also do a demo on how to set up a data agent. And then finally, we're going to go into some specific code-first features in Fabric for implementing AI functions and looking at some of the capabilities with those. This is not meant to be an exhaustive set of reviews around the AI features in Fabric. There are many, many more AI features. These are kind of the top level ones that most people would begin with. Then we'll go into a little bit of a Q&A at the end. And also, just as Martin said, if you have questions along the way, please throw them in chat, but we won't get to them towards the end of the presentation. So quickly, what is Fabric? So the whole concept behind Fabric is Microsoft is trying to build this unified platform for data. It started off as a platform for analytical data specifically. That is where its roots are, but it is very rapidly growing into more of a generic data platform. Recently, they introduced databases inside of Fabric. And when I say databases, I mean like your traditional SQL server or like a traditional Postgres and things like that. So not necessarily analytic forward databases, but more operational or application-based databases. And so that's kind of the first foray into expanding Fabric beyond analytics. But the best way of just thinking about it at a high level is that this is a software as a service data platform. It has everything that can be unified here, meaning that they all talk to each other, the different components. They all work with one another, and they can all be built upon one another. So that's kind of the general concept here of what Fabric is. Fabric is also built upon kind of four key tenets. The first of this is this idea of it being a complete platform so that everything that you need is under this one umbrella. The second is being open and lake-centric. And essentially what this means is that it is built around the concept of a data lake, and the features of this data lake are using open source standards so that it is open, anyone can integrate with it, any tooling can communicate with it, and so on. Third pillar is about empowering business users. Most of this has to do with how the system is laid out, how it's organized, and the general user interfaces around this. But the last one is what we're going to talk about today. is Fabric is being built with this concept of AI powering it from the ground up. So these AI features are not necessarily bolt-ons. The whole design around Fabric is being built with understanding that there's different avenues for AI to inject into your workloads. And so it's very much an AI first type of platform around a lot of these different topics that we'll talk about. And again, that's where we will be focusing most of our discussion today. So let's get into Copilot here first. Copilot is very quickly becoming kind of a universal entry point for AI across Microsoft's entire stack. It's in M365, it's on your laptop, it's everywhere. It's in the browser, it's in, Bing search, it's everywhere that Microsoft has some sort of connection, they're implementing a version of Copilot. And that is no different with Microsoft Fabric. So Copilot is an integral part of Fabric as well. And the whole idea here is that Copilot is there to help accelerate your data development and help accelerate getting to your answers for data quickly. That doesn't necessarily explain very well as to what it is. The main concept here around Copilot is that this is a natural language chat interface. So you are chatting, you are typing, or in some cases where there is voice allowed, you may even be talking to a large language model for an AI. And there's kind of two different areas that we'll get into a little more later around Copilot. But the primary area within Fabric is around accelerating productivity. So the features and functionality that this chat assistant is helping with is answering questions about the technology, how to do something, how to write certain code, how to maybe build a specific transformation to clean up your data. And that's kind of the main purpose around what Copilot is trying to do. And there's some hints again here in the name. Copilot is not meant to go and do these things necessarily for you. It is your co-pilot. It's your companion along your kind of development, life cycle as you're going through. It is assisting you with this productivity and helping you along the way, but it's not necessarily a fully autonomous AI that is meant to do these things for you. So from an audience perspective with Copilot, the primary audience again is the developer audience. This is changing pretty quickly, and we'll talk about some of these changes here in a moment. But that is the initial audience is around enterprise developers and self-service users that are building assets within Fabric. It could be a report, it could be an ETL pipeline, it could be building out a lakehouse. There's lots of different methods to interface with Fabric, but it's primarily around that development productivity. Where this is starting to change is around Copilot giving you insights into your data. And that is where it's starting to fit more with the business user audience. And this is a little bit slow to come, but a lot of the features that we're going to be talking about today are solely aimed at getting that sort of insight out of your data. So it's the faster growing side of this as well. The goal with Copilot inside of Fabric is to be available across every workload inside of Fabric. And again, we didn't really spend a whole lot of time going over this kind of concept of workload, but that is how Fabric is organized into these different tool sets. So when we talk about that first pillar of Fabric being a complete platform, how it fulfills that is through enabling these various workloads. And these various workloads are targeted at different personas. So for example, if you are a data scientist, you may very well be using the data science workloads within Fabric. And there is a Copilot experience for that. And these various Copilot experiences are being tuned to the various personas within those workloads. So the user experience in, say, let's say in the real-time intelligence Copilot is going to be very different than the user experience in the Power BI Copilot because of the way it's tuned for that specific workload. As you can see here, it is spread across most of the workloads inside of Fabric, but many of these copilots are not generally available. They're either in public preview, and there's a few options that we'll talk about later that are actually still in private preview. From a supported item perspective, Copilot shows up currently in these items. So things like data flows and pipelines shows up in notebooks. Power BI side, it'll help you with semantic models and reports. Databases, it'll help you write SQL queries for a SQL database. The real-time intelligence is mostly around KQL and some of the real-time dashboards. And then finally, it's available with the data warehouse asset. And so there's some notable things missing here, and a lot of those places that are missing is where some of those private previews come in. For example, Data Lakehouse is missing from this list. There currently isn't any sort of support there for Copilot. I alluded to this a little bit earlier, but there really is kind of two faces to Copilot within Fabric. And you're not necessarily going to see this everywhere with Copilot across other product stacks. It's a little bit of a unique scenario here with Fabric specifically. So we have this kind of primary persona of Copilot that's this builder Copilot. It's really there to, again, accelerate your productivity and help data professionals build things. This is where you will find it in most of those assets that we mentioned just in the last slide. So for example, in a notebook, it can help us generate our PySpark code, or it could help us write DAX queries for a Power BI semantic model. It can help us generate transformations and data flows and so on. The newer half of this is more around the semantic Copilot, where Copilot is attempting to give insights into the data that is part of your environment. This will help users ask questions around that data and get natural language insights back. So you can ask Copilot, for example, to summarize this report. Tell me what this report is trying to tell me. What are some key insights that I should get from this visual, those type of things. Or you can ask very pointed questions as well, like give me the top 5 customers in the state of Missouri for sales, and it could return some of that data for you. So it's always in kind of a chat-like interface that you are working with here from a Copilot perspective, but it's there to give you that semantic context around the data, not necessarily in this scenario, help you generate new code. So if you've played around at all with Copilot up to now, you likely see that the Copilot is relatively powerful, but there's a lot of limitations here, and people tend to get pretty frustrated with it quickly. One, it's not magic. It doesn't just inherently understand your environment. It doesn't inherently understand your data. It is extremely dependent on the quality and the availability of the data within your environment. So just having Copilot is not enough to make it useful. And that's where we're kind of going to go in this next side of this is what do you do to help optimize Copilot to actually get the most out of it? First, the main thing you want to do is be able to ask better questions. And we'll go over some examples of what we mean by asking better questions. But the more kind of content you can provide in your prompt, the more direction the AI has to know exactly what you're looking for. And it will give you better results back just from that alone. Then there's an entire set of kind of data best practices inside of Fabric, ways that we are going to enhance our data with additional metadata, the way that we're going to structure our data, those type of things that allows not just CoPilot, but users in general to get more out of your data environment. Then there's some specific settings that are around Copilot. First is the set of Q&A settings. We'll go over what these are and how they impact the Copilot model. And then finally, there's a new concept. This is in preview. It's called verified answers, and it allows us to kind of shape a little bit about what Copilot is returning to our end users. So let's jump in first with kind of asking the better question side of this. Number one rule, be specific. So, the example here is the bad question is, how are we doing? That is not specific. How are we doing in what context is the problem that the AI model is going to have? So really we want to narrow this in, and it's kind of prompt writing 101. Any of these large language models are going to benefit from these sorts of better prompting. So just keep that in mind. This is not unique to Copilot by any means. You could apply these same type of, question prompt building to something like ChatGPT or Claude or Gemini or any other AI large language models that are out there on the market. But the number one rule again is be specific. Be specific with what you're asking for. Be specific on what you want the AI to actually return for you. The more specific you are, generally, the better your results are going to be. So number two, include context. So not just asking about how we're doing, but let's box this in a little bit, add some time frames. Let's do it maybe as a comparison. It's not so much I want a time frame here, I just want to know how we're doing compared to X, whatever that X is. Three is use business terms from the model. This is extremely important right now from a Copilot perspective because how that data is laid out in Fabric is how Copilot is going to see it. So if we are using, instead of the word customer, we're using the word prospect as an example inside of our data, uh, Copilot isn't going to necessarily translate that on its own. It's not going to know that these are one and the same. And so it may miss that additional context. We're going to talk about here in a second some best practices to get around that, but just keep that in mind. How the data is laid out in your environment is how you need to talk about the data. Number four here, ask one thing at a time. This is also going to generally get you better results. Instead of loading up a ton of questions, you do it as a little more of an exploratory. So we start kind of with the top thing that we're looking for, and then we'll start refining it with additional prompts until we get to where we want. So treat it more like a bit of a conversation here than you would treat it like I'm just throwing a paragraph of information that I want from the AI. Five here is to be more analytical in how we're writing this. So you do need to think a little bit about how an analyst may look at this and how it may benefit to form this a little bit like a query. Again, we're talking about natural language. We're not writing SQL queries. We're not writing DAX here. But what I mean by think of it analytically is if you were to dissect something like a SQL query, we start off with this kind of concept of what am I pulling from, right? I'm grabbing data from something, and then I'm specifying exactly the kind of the detail in terms of the columns that I want for that data. And then I'm adding some predicates here that help filter it down in the form of like a where clause and so forth. And again, you would be doing this in natural language, but think about it in that kind of a hierarchy. What am I asking about? Maybe I'm asking about sales. Okay, well, what do I actually want to know about sales? Well, I want to know which products were our top sellers and maybe which regions were. And I want to know this to filter it down a little further for 2024 and within our North America geography or something along those lines. That is thinking analytical rather than I'm just, talking with a buddy type of thing. And last, I already refined this, or I alluded to this in four, but we want to iterate our prompts. Instead of doing these massive prompts, think about it in a series of steps. Oftentimes, it's easier for the large language model to start with a single command, like give me total sales. And then you say, okay, well, now filter that down to 2025 and so on. And you can continue to work with them across a series of prompts instead of trying to lump it all into a single prompt. Just this one thing here of asking better questions is going to go a long way towards improving the results that you get back, again, from any of these large language models, but explicitly here for Copilot. So next we have a whole series of kind of best practices within Fabric that we want to follow. And I'll reiterate here that we are talking about Fabric, we are talking about Copilot, but these same best practices really apply to any sort of modern analytical environment. There's a reason why we have certain methodologies and practices and so forth within data analytics. And a lot of this is to make it more user-friendly for humans. But that human readable nature of some of these models also goes a long ways towards enabling large language models like Copilot to be able to understand this data as well. So from a data modeling perspective, there's a handful of things here. One, whenever possible, I would say it's almost entirely essential here. You want to be structuring your data as a star schema. It is much, much easier for the large language model to iterate over a star than it is a more relational model where it has to do a half a dozen joins. So this is a very important aspect of it when you're asking data questions from these large language models. Simplify the data model, and the best way to simplify that data model is star schema. Next, make sure that your tables are split into clear dimensions and facts. What I mean here is it is a common scenario where in data modeling terms, we would use what are called degenerate dimensions. These are descriptive fields that are still on the sales order or something along those lines. They're still attached to the fact. It is much better from a clarity perspective for something like Copilot to discretely separate that into its own table, its own dimension, even if that means that we now have more dimensions kind of circling our fact than we would otherwise, which results in potentially more joins and so forth. It makes it very clear where we're drawing this line in the sand between what are our facts or our metrics and what is our descriptive data. So it's another important kind of best practice here when we're doing our data modeling. Another thing, every dimension should connect directly to a fact table. This means that we're not doing any dimension to dimension connections. So we're not snowflaking our star schema. In other words, we're keeping our star schema pure. If we need it to relate to another dimension, it needs to traverse through a fact table to get to that. That may mean, from a data modeling perspective, we need to introduce some concepts like factless fact tables. I know that's probably getting a little more data modeling detailed than we need for this conversation, but just the rule of thumb here is simple. Dimensions should only join to facts. They should not join to each other. Next, fact tables should always focus on an atomic event, meaning what we're looking at here is what exactly happened. I'm not trying to roll things up. We will let the system do aggregates. So instead of aggregating sales by week or month or something like that, I want the individual sales transactions. That is where my facts should be. That's going to allow the most flexibility in terms of asking questions of our data models. I already mentioned this above, but it's related and a little more specific. But again, avoid degenerate dimensions. We want that clear split between dimensions and facts. And we also want to hide irrelevant fields or technical fields. What I mean by this is things like keys, things that are various codes and stuff that don't actually matter from an analytic perspective. Hide them, get rid of them from the fields, or if they're tables that are just there for metadata lookups, get rid of them. All it does is it creates noise for the language models to have to walk through. So next, around naming. We want to name everything as human readable as possible. So where we can, we want to use business terms and we want to use it in proper cases with spaces. So we're not doing camel case, we're not doing all uppercase, all lowercase, we're not abbreviating. We are actually writing this out. So instead of, like total underscore sales, it's just going to be total space sales. And so a lot of this, when we're talking about this, though, we are somewhat removed from the source, right? Because we're talking about now some sort of semantic layer that is right before your users are interacting with this. This is where we want to apply these business terms. And again, we want it properly cased, we want it properly spaced, we want it to be human readable. So mentioned this already, but no abbreviations, avoid jargon, don't use prefixes. None of that means anything here from a clear language perspective. And then there's just some general guidelines. Dimensions should be singular, facts should be plural, that sort of thing. What's more important, though, than this is just be consistent. If, for instance, you want to be plural on your dimensions, fine, but make sure you're doing that everywhere, not just on a single dimension or something along those lines. Next is around metadata. Power BI specifically, but a lot of other areas within Fabric too, provide layers of metadata that allow us to describe the data that we're looking at. We can label certain columns as being keys or the label for a table. That is very important to help, again, the large language model understand how to navigate through our data model. We can always make sure that we're adding descriptions. This is something that we tend to be lazy on when we're designing these things and not do it, but every single attribute should have a text description. Every single table should have a text description. Luckily, this is actually one of the areas that Copilot can help us as our assistant, is Copilot can generate a lot of these descriptions and so forth for us. Granted, it needs to have some context to understand what the attributes and tables are, but if you give it that context, it will generate these descriptions and set them for you. So it's already gives you some ability to speed this up on that side of the house, the development side of the house. We also have the ability to categorize our data. This is, again, especially true with geography elements, things like city, states, street addresses, those type of things, that it can provide some context to the large language model. We can format consistently. We can make sure that we are using explicit measures only. And what I mean by this is that instead of taking the column inside the fact table, we would be wrapping these measures in DAX. And this is a kind of a Power BI best practice anyhow. I'm not going to get into a lot of detail of it, but it is one of the things that will help Copilot navigate better. And if we do have calculated measures that are complex, make sure we're explaining how the measure is calculated in the description. This will help, again, Copilot understand how this measure is perhaps related to other attributes and so forth. It's also just good practice in general. You come back to this in a year, you may not remember at all why you wrote this calculation the way you did, including that kind of description in the measure itself, along with that attribute, goes a long ways to help clear some of that up and document your environment. So that, again, is kind of the key here to both the naming and the metadata, is we want to document, and make things as clear as possible, because it's that documentation that will ultimately drive some of this. So beyond best practices, though, we do have some Copilot specific settings. First, when you're working with a semantic model, you have the ability to turn on Q&A. Q&A is an old feature from Power BI. It's been around for years that allow you to ask natural language questions of your data, but it's recently gone through some upgrades to have it more properly integrated with Copilot. And there are some settings here. First, you have to enable it, but then when you have enabled it, there are some settings within Power BI Desktop Right now, these are only Power BI desktop features that should be coming to the portal soon, but they allow you to do two things. One is set up synonyms. So I can give examples here for the large language model that says employee and associate are the same thing. So if someone is asking about associate, what they really mean is an employee. So I am setting up a bunch of synonyms around my various terms that are in my data model. So this corrects a little bit of the problem we talked about earlier, where you always have to use the language as it's described in the data set itself. This allows us to describe it in multiple ways. I can have many synonyms associated with a single attribute here. The second, and this is a newer feature, is this idea of establishing linguistic relationships. So I can set up this as a set of terms, a who does what sort of scenario. And this allows me to linguistically join something like employee and product together, that an employee sells a product. And you can go through a bunch of these different term relationships. And so then when you are asking these things in natural language, it is able to translate this concept of, well, this employee selling this product is really what gets me to my total revenue or something along those lines. And so it's just a helper for the large language model to help navigate your data model. The last feature, and this is a preview feature, and it's a new preview feature, so it's only been around for a few weeks now, is this concept of verified answers. And what this lets you do is if you already have an approved visual or something inside of one of your reports, and this is the visual that is meant to explain this set of questions, you can assign it as a verified answer. So it's essentially your way of endorsing this particular visual. So now whenever anyone asks about this, so the screenshot here is showing a chart that displays churn for customers, I believe. And so whenever a customer churn question were to come up, this visual would then be presented to them. And it's a live visual. They can filter it and change the context and so forth. And in fact, you can, when you're setting up your verified answers, you can adjust some of the slices and dicing of it through your filters and slicers and have different kind of sub questions related with that. It's a nice way of essentially pre-prompting these answers based on what you believe your customers or your end users are going to be looking for. So let's move on past Copilot here for a moment, and we'll get into some data agent stuff. Mentioned this at the beginning, but data agents have gone through a rename. They were originally called AI skills. They were introduced last fall. I think last November is when they were introduced. And they've been in preview for a while. What this is essentially a way for us to build a custom generative AI experience around our data. So think of it as kind of a custom version of Copilot, where we can explicitly set it to understand a certain data set. So let's say we wanted to build a customer service agent, and we want this agent to be able to answer questions about our customer service past performance and all of these sorts of things. We can then define a narrow set of data that answers these questions and associate that with this data agent. And now that data agent, if we've done our job, should be able to answer questions about that specific topic. So it's narrower in scope than something like a broad Copilot, but it also has the ability to be integrated with something like Copilot to expand Copilot's capabilities of being able to answer these domain-specific questions. And again, we'll get into a little more concrete definition of what this is and how it's built here in a second. But the idea is that we build these data experts, these data agents, we refine them, and then when we are ready, we will share that with the wider audience. And it uses the agent itself is essentially a translation layer to take it from the questions that the end users are asking, and it will generate either SQL statements, stacks, or KQL statements for the underlying data sets to go fetch that data live and in real time. So your data as an agent here, it is a conversational data agent, so it allows you to interact with it naturally. There's a bunch of new debugging capabilities that allow you to help refine and understand the responses that you get from your data agents better. This is some of the new features that were released in April around this. It is seamlessly able to reason over a wide range of data sets. So everything from semantic models to lakehouses to warehouses to event houses, and therefore it acts as kind of a data expert. So you're not writing the queries to do this. It is doing it on your behalf based on your questions. And then again, as I alluded to, ultimately, your data agent is then consumed either inside of Fabric or outside of Fabric through things like Copilot Studio and Teams, or things like Azure's AI Foundry. And also there's some ability for it to be integrated into custom applications. So from kind of an end-to-end life cycle here, what we are doing is and we'll walk through this in a demo. It's very, very quick and easy to do, but we first create a new data agent. By creating this, it inherits all of the features inside of Fabric. It will have data lineage tracking. We can manage permissions. We can share it, so on. We then assign some data sources to it. And the data sources that are currently available are lakehouses, warehouses, event houses, and semantic models. Then within that, we select which objects we actually want to be part of our data agent to refine it down further. We then have the ability to configure it. We can configure it by creating some additional instructions. So for example, we could say you are a customer service data agent. You need to be able to answer questions about X, Y, Z, whatever that happens to be. So we're giving it some additional instructions. And also in those instructions, we could provide some translations for it, similar to the synonyms that we talked about earlier, where we could say, employee is the same thing as associate. We can give them those type of instructions in line as part of our configuration. We also have the ability to provide some example queries. So we would give it an actual, let's say, SQL statement for a set of questions so it can understand how to navigate our data model a little bit better if it's having trouble with it because, I don't know, maybe our model's not very well designed. We don't have referential integrity and joins established and so forth. So we want to give it some example queries on how to do it on its own. When we have it in a state where we think it's ready, we can now publish it. It now becomes a versioned agent, and that versioned agent can then be consumed downstream in a variety of services. There's a couple notes though. This is all preview here at this point. Everything we're talking about is in either public preview or private preview. So there are some preview notes. These agents can only read data. They have no ability to do any sort of write back. They are limited right now to no more than 5 data sources. They're focused entirely just on data retrieval, and they can only access structured data. And what I mean by that is your lakehouse may have semi-structured data like JSON files and things like that in there that are part of it. It's really only able to access the tabular data that's available in something like a lakehouse today. You don't have any choice over what large language model is being used in the background. That is all part of the service. It's managed for you. So there's some limitations in the configuration that's available. You cannot have more than 1,000 tables at this point and no more than 100 columns in any one of those tables. So there's some limitations in the size. Again, these are preview limitations. I expect most of these things to go away before it is fully GA, but there are limitations on some of these things. Again, and complex models that are going to have many joins tend to lead to poor quality results. So let's talk about some of the integrations that are available. First, we have Azure AI Foundry. This is available today in public preview. If you have Fabric, you can go utilize this today. The data agent itself will show up as a knowledge source inside of the AI Foundry, and you can utilize it like any other knowledge source inside of AI Foundry and integrate it into your custom applications from there. The whole purpose of this, though, is it gives you a grounded AI agent to use as that knowledge source for whatever custom apps that you're doing. Also in public preview is a data agent SDK for Python. This allows you to load it into things like notebooks or write custom code around Python and so forth. It is based on the Assistance API from OpenAI, so it utilizes a very standard kind of method of evaluating this. Primarily, though, this is used for test automation. It's not necessarily used for creating applications. Private preview, we have a new feature that was announced last month. It's supposed to be rolling out here soon, and that is CoPilot, what they call home. And essentially, this is CoPilot instead of living in all of those different workloads that we talked about earlier. This is a centralized CoPilot that just lives in the menu inside of Fabric and allows you to ask global questions of your Fabric environment. And so by integrating these data agents there, you don't necessarily need to know where that data lives to be able to ask questions about it. Right now, the way that Copilot works inside of Fabric, you have to go to the specific workload, the specific report, whatever it happens to be to interface with it and ask those questions. This global kind of home version of Copilot should fix a lot of that. Also in private preview, although I believe this is supposed to be released here very, very soon, is the integration with Microsoft Copilot Studio. This is what would allow you then to take your data agents and bring them into something like Microsoft Teams. All right, so moving on now to AI functions, and then when we're done with this section, we'll get into some demo. So on the AI function side of this is a set of functions that are just built in that allow you to readily use some AI capabilities. They're primarily there to help you transform data, enrich data, and this is a code-first experience. And you'll see what we mean by that in a moment because we will be interacting with it through some PySpark. And generally, it wraps an OpenAI large language model. The interesting part of what functions are available. There are similarity functions, classification functions, sentiment analysis, and so on. There's also a generic prompt response where you can just ask questions around it. The translate text option in this it is it uses a large language model that has been trained on a wide range of data, so it has a pretty good ability to translate. But from a tested perspective, it's only been tested on Czech, Finnish, French, German, English, Greek, Italian, Polish, Spanish, and Swedish. So your mileage may vary on any other language you're trying to translate, but it doesn't necessarily have limitations on translating those languages. It's just they have not been fully tested. Excuse me. Like all of our other previews, there's some limitations while this is in preview. The biggest one here is there is throttling on these. You are currently limited to 1,000 requests per minute. And again, this is a throttle that is part of the preview so that people can't, just run away with it while we're testing it out and doing so forth. But this is a pretty extreme throttle. If you have a data set that has more than 1,000 records in it, then you're guaranteed to wait at least a minute for the results to come back because of the way the throttling works, and that can be pretty slow. So this is not necessarily a feature that is fully ready for production. There's also another limitation here is that you don't currently have the ability to switch the data model that's behind it. It is using GPT 3.5 Turbo for this, which is a fairly old model at this point. And again, this is just a limitation right now of the preview. And it's also optimized for English first. So let's jump into some demos here. Let me switch. So I am inside of Microsoft Fabric, and I'm inside of just a workspace that I have set up for this demo. And I have two primary data sources set up. I have a lakehouse that is built around Microsoft sample data for their worldwide importers. And this is a pretty traditional data model. It's just a sales data model. And I have built a semantic model around this, and we can very briefly kind of look at it, what it looks like. It's just a simple star schema, sales fact in the middle, surrounded by a handful of dimensions. And what we'll do here is we're going to create a new data agent for it and see if we can ask some questions of it. So I'm adding a new type, data agent. Again, this is in preview. So hopefully the demo gods are with me today and it will work. So we've created a new empty data agent, and the first thing we do here is we add a data source to it, and we are going to add that semantic model we just looked at. And it'll take a second for it to grab it and load it into the agent. Once we have it in the agent, we can view which tables are available. We can see the columns and so forth that are here, and we select which of these tables we want to be available for our data agent. And that's really all there is to setting it up. I could add additional data sources. They can also be different types of data sources. I can mix and match. So I could add a lakehouse in here and so on and so forth. But let's give it a try. So it has some sales data. So let's ask it, what are the total sales for Missouri? And this is not going to be super fast. What it is doing though here is it's going to go out and interrogate your model. It's looking for those kind of keywords that I used here. You know, what it's looking for the total sales, it's looking for things like the geography elements for Missouri. And what it ultimately is doing is it's taking that and it's generating some code for us in the form of a DAX query. And so I can view the query that it used to find this. So it's hitting my total sales and it's getting it for the state province of Missouri, and it returns our amount here. And I can ask other as well. What are the top 5 states by, let's see, I don't know. There's a measure over here called dry items sold. So it's kind of a obscure one, but let's see what it does for us. And again, it'll work on this for a moment because it does need to translate this. And so it can be a little on the slow side at times, but it should hopefully give us back what we're looking for. So here's our top 5 states. Again, if I wanted to get into this, I could look at how it's doing this. And I could change context here too. I've just been looking at the states. So maybe I want my top 5 customers instead by like profit margin or something like that. Um, and again, it should be able to go find this. It's a pretty simple model and it should be able to interrogate this and do this. If, on the other hand, though, I needed to provide it with some additional instructions, I do have that ability here. So I can explain the data sources. I can give it common examples of questions and answers. I can translate different topics for it. I can give it instructions on how I want it to treat certain things. Like I can get pretty specific with it. Like example here is where it's returning this customer, I could give it instructions to say that always also return like the customer ID along with the name when we're talking about a customer or something along those lines. And those instructions then get followed. I do have the ability to provide example queries as well. This is not currently supported though for semantic models in the preview. It's only supported for SQL and KQL right now, not DAX. So this is not available. When I, again, have this ready to where I want it, I can publish it here. I can give it a description so that people understand what this data agent does, because that's the description will show up in places like the AI Foundry and so forth. And it's now published to my tenant, and I should be able to use it in those downstream applications. So that since we're running low on time and I want to make sure we have time for questions, let's jump straight into the AI functions. And I just have a simple notebook here, and I'm going to connect this notebook while we're talking. And what this is doing is I have a data set, a lake house here that has hospitality reviews for essentially hotel stays over like a decade period. So it's a whole bunch of hotel stays. And if I grab a sample of this, I'm just going to grab 100 records from it. This will take a second because it's not warm and it needs to warm up, but it should go and grab 100 different review examples. So it's going to give me the text of their review, maybe. Not sure why it's having a cache issue, but it did return what I'm looking for. So if I click on one of these, we can see here on the side, it's a long text review of their hotel stay. Apparently, this is the library hotel, and it was fantastic. This, though, from an analytics perspective, doesn't give me much to work with. It's hard to be able to parse a long piece of text like this. So maybe I want to get some sentiment analysis out of this. So let's go up here to our menu. We have a menu called AI Tools, and I want to set up an AI function. So I want to detect the sentiment on these reviews. So I'm going to pick the data frame that I'm using. It's this DF reviews, and my sentiment analysis needs to be on this text review. So I'm going to pick the text. And I'm just going to leave the code as is. I'm not going to modify any of this, and I'll walk through it here in a little bit, but we'll run this because it takes a second to run. Again, mostly because of the throttling that I'm talking about in this preview. But all I'm doing is I'm importing the functions. I am setting up the model. Again, this is the only model that's available right now in the the public preview of this, but other models should be available in the future. I am passing in the data frame that I want to analyze. I'm telling it I want to do sentiment analysis, and it's on the text field, and it should be returning here shortly, hopefully. And what it's going to give us back when it does return here is it's going to give us a column for the sentiment itself. And if there was an error, it would capture this. There's no errors here on any of them. But let's take a look at one of these negative ones right here. The room was very small, and the cleaning people stole my iPod. Yeah, that I guess is a negative experience. So it seemed to have detected it fairly well. Here's a neutral one. They're just kind of telling you a little bit about their stay. They're not necessarily positive or negative, it's just neutral. But the point is that it's giving us some sentiment analysis back very simply. We didn't really do much here other than integrate with this particular function. But I could take this further still. Maybe I want to categorize the problem here with the sentiment. So I'm going to categorize the text. I am going to grab our sentiment data frame. It's going to use that same text analysis. And let's say I want cleanliness, and I'll type the others in when we get it. So I'm just going to give it two quick categories. And I think I have a little cheater over here that can grab some of these. So this code, though, what it's doing is we're giving it a series of keywords that we want it to categorize the text based on. So it's saying, what is this text about? Are they talking about the cleanliness? Are they talking about amenities? Are they talking about cost? Is it something altogether different? That's why we have this catch-all of other. But it's going to go through and run this now, and it should help us categorize those individual sentiments. So this then allows us to do even further analysis for this. So now we could bring this into a report or whatever it happens to be, and very quickly, slice and dice all of our reviews based on their sentiment and based on the categorization of that sentiment. And again, it's going to take a moment, but it shouldn't take too long. So while this is returning, though, just a couple things to point out. This is a code first environment. This is all being done in Python. This is available outside of Python as well. There are stored procedures in data warehouse for doing this. So we could write SQL queries to do a very similar thing to this. It doesn't have to be Python. But even though that this is a code first experience, we haven't written any code here. Everything is being done by the little setup helper. It allows us to, continue to modify this. Like I could have added those other categories in here by hitting the plus and just adding more. So here we are. So now we have both our sentiment and we have whatever the problem is. So right here, we'll look at one. The hotel seemed good at first, free parking, but I paid for Wi-Fi. Okay, not such good English in here. Um, and the guy from the front desk was rude. So that seems to fit with the staff and service as being the overall category of why this was a negative experience. It was rude staff.
We do appreciate everybody coming and joining today's session. Thanks, everybody.
Thank you.
Thanks, everyone.